Atherosclerosis is a disease of the arteries in our bodies, in which fatty material is deposited in the walls of our arteries. These deposits produce something called plaques. Atherosclerosis causes heart disease, most strokes, and peripheral vascular disease, which is when blockages occur in the arteries carrying blood to our lower extremities. It is estimated that atherosclerosis affects 20% of the population in the United States, or 58 million people, and the figures would be consistent worldwide in many of the industrialized nations. Every year, 1,500,000 Americans have a heart attack, resulting in 500,000 deaths. Especially alarming is that 250,000 of these deaths occur within 1 hour or less of the episode. And for many, the first symptom is death. 600,000 Americans have a stroke each year. 160,000 of these victims die. And there are 4,500,000 stroke survivors in the United States, many of whom have a diminished quality of life due to the inability to speak, or who have paralysis affecting their limbs or other impairments. There are millions who have decreased mobility due to arterial blockages in the arteries that carry blood to their legs. Often just walking short distances causes such pain that they have to greatly restrict their activities. Until recently, we've had a very simplistic view about how atherosclerosis develops. It was cholesterol, cholesterol, cholesterol. If one ate a diet too high in unhealthy saturated fat, it was felt that the resultant cholesterol simply gunked up the artery until the channel carrying blood through the artery was so narrow that blood couldn't get through, and you had a heart attack or a stroke, or your legs began giving you pain. Now we have a new understanding of the atherosclerotic process. Much has been written in both medical journals and the popular press about new discoveries that you need to know about. Because there are natural nutritional supplements that you can consume that can give you a greatly enhanced probability of not being a victim of a heart attack or a stroke or of developing peripheral vascular disease. There is an amino acid in our bodies called homocysteine. Here is the chemical structure for homocysteine. And here on the screen is a schematic of the major pathways for homocysteine metabolism in the liver and kidney. You needn't worry about remembering these last two slides. They're shown simply to let you know that much is understood about homocysteine. But here is a graphic that you need to remember because it reveals the relationship between elevated homocysteine levels in your body and the risk for heart disease. For every 3-unit increase of your homocysteine level above 6.3 micromoles per liter of blood, there is a 35% increase in cardiac risk. So, a level of 9.3, a 35% increase. 12.3, an additional 35% increase in risk. 15.3, another 35% increase. Many labs report that 15 micromoles per liter is a normal value. 6.3 is the optimal level for the risk for atherosclerosis, according to a now well-accepted article published in Circulation as far back as November of 1995. So let's walk through how atherosclerosis develops in your arteries. Besides elevated homocysteine levels, infection has now been implicated in atherosclerosis. The common infectious agents involved are herpes simplex 1 and 2, which cause cold sores and genital lesions; cytomegalovirus, one of the causes of mononucleosis; Helicobacter pylori, known to cause ulcers; chlamydia pneumoniae, which causes many respiratory infections; and pathogens or germs which cause periodontal disease, like the gum disease called gingivitis. And cholesterol, once thought to be the only or at least the principal risk factor in atherosclerosis, is still an important factor. On the screen, you'll see a diagram of an artery with various cutaways to reveal the internal structures. The next slide shows where elevated homocysteine in your blood has damaged the lining of the arterial wall. This damage increases the permeability of the wall of the artery, which means that it is easier for whatever is circulating in the blood to enter through these damaged areas and to get inside of the artery, into what is called the intima of the artery, as demonstrated here. If one of the germs that we just mentioned goes through the damaged wall and sets up its residence there, your immune system senses a threat, and it gets into its action mode and follows the threat. It sends white blood cells called monocytes into the wall in order to combat the threat. Monocytes get into their fighting form by converting to macrophages, which literally is translated into big eaters, because that's what they want to do, to actually remove the germs by grabbing them and eating them, as you'll see displayed here. Meanwhile, cholesterol, bad cholesterol known as low-density lipoprotein, or LDL, also enters the picture because it seeps through the homocysteine-injured arterial wall, and the higher the cholesterol level, the more that can infiltrate into the intima, the inside of the arterial wall. And then homocysteine again enters the picture. It latches onto the LDL cholesterol and it oxidizes it. Oxidation is the process that causes an apple that is cut open to turn yellow or a car to rust. Oxidized LDL cholesterol goes from being bad to being really bad, to now having the potential for being really harmful, because those big eaters, macrophages, simply can't stand the temptation of feasting on that oxidized LDL. They originally went in after the germs, but they get diverted and start gobbling up the oxidized LDL cholesterol, and they balloon up to enormous size, and if you look at them with a microscope, they literally look like they're filled with foam. That's what scientists call them, foam cells. And foam cells are what make up the plaques, which are what we know as atherosclerosis. So depending on where these plaques accumulate, you are now a perfect candidate for a heart attack, a stroke, or for incapacitating arterial disease in your legs. Here's what happens. You see this foam cell-filled plaque in the wall of your artery? Your natural healing process forms a cap over the plaque. This is an attempt to seal the plaque off, but it also adds to the size of the plaque and causes it to bulge into the area inside the artery where blood flows. Various chemical mediators get involved, and a fissure and opening can occur as shown. And bleeding occurs from the damage where the fissure forms. Clotting factors cause this bleeding to form a clot, and the clot blocks the arterial blood flow. And now you've had a heart attack or a stroke, or you've clotted off a leg. Blood that carries oxygen can't get through. Cells in your heart or brain or lower extremity are deprived of that life-sustaining oxygenated blood, and they suffer injury or death. And you suffer injury or death. We discussed the risk factors now recognized as being implicated in atherosclerosis. We discussed how atherosclerosis can result in heart attacks, strokes, and peripheral vascular disease. The three risk factors discussed were elevated homocysteine levels, certain infections, and we'll explain the infection connection in more detail, and elevated cholesterol, especially elevated so-called bad cholesterol, called low-density lipoprotein, or LDL. We would not be complete in our discussion if we didn't list other risk factors known to be important in atherosclerotic risk. These include smoking, high blood pressure, diabetes, being overweight or obese, inactivity, stress, and excessive alcohol ingestion. Age and heredity also play a role in the risk for atherosclerosis, but these factors are pretty much beyond our ability to influence. We can lower our risk by lifestyle changes, which we all know are easy to talk about but often difficult to achieve. Easier to achieve is the lowering of our risk factors through intelligent nutritional supplementation. Let's address homocysteine again. We learned in Chapter 5, as you again see on the screen, that any level of homocysteine in your blood that exceeds 6.3 millimoles per liter increases your risk of having a heart attack, and that each 3-unit increase increases that risk by 35%. Homocysteine responds to vitamin supplementation, notably vitamins B6, B12, and folic acid, which is vitamin B9. If your homocysteine level is elevated above 6.3, a cocktail of these vitamins should lower your level to a more healthy level. Sometimes the addition of betaine, also known as trimethylglycine, or TMG, can be added to the B vitamins to help in the lowering of especially high levels of homocysteine. We mentioned infections by common germs as being implicated in atherosclerosis. You'll remember what happened when the big eaters called macrophages went through the homocysteine-damaged arterial lining. They had the intention of finding and literally eating and thus killing the germs that had gotten into the arterial wall. But they got waylaid by the homocysteine oxidized, tasty LDL cholesterol, and by stuffing themselves, they turned into the foam cells that constitute arterial plaque. What happened is called inflammation. When white blood cell germ seekers such as macrophages try to do their duty and protect us, they are part of the immune system's inflammatory response. Let's read this illustrated explanation from a recent magazine article together, which is entitled, How It Goes Wrong. If the inflammatory fires refuse to die down or flare up for prolonged periods, permanent damage may result. A long-running, low-grade infection, like gum disease, may keep immune cells fired up, or there may be a breakdown in the complex series of checks and balances that regulates the immune system. Certain parts of the body are mistakenly selected by immune cells for attack. Macrophages start chewing up cholesterol deposits in the coronary arteries, or glial cells begin destroying neurons in the brain. The body's efforts to heal the damage it created end up only making matters worse. How ironic it is that our immune system's efforts to protect us can actually backfire and cause us harm. We now realize that chronic inflammation is the cause of many disease processes in our bodies. And the most devastating of these diseases is atherosclerosis and its consequences, heart disease, most strokes, and peripheral vascular disease. There is a test to measure inflammation in your body, and it's called a C-reactive protein test. A specific C-reactive protein test for arterial disease from plaque formation is called a high-sensitivity CRP, or HSCRP. Everyone who's being evaluated for heart disease should have an HSCRP test done. It isn't expensive, and it's highly recommended. Dr. Paul Ridker, Director of Cardiovascular Disease Prevention at Brigham Women's Hospital, has stated that C-reactive protein levels are actually superior to LDL cholesterol levels in predicting cardiovascular events. A cover story in U.S. News & World Report was titled, The Heart Test That Could Save Your Life. On the screen, you'll see an HSCRP ranges and disease risk chart. Please become as informed as possible and have your physician order this test. And if you fall into a level where you are at risk, here is a suggestion about what you can do to lower your risk profile. Chronic infection from common germs has been implicated in causing the chronic inflammation that can occur. Remember those macrophages ingesting the oxidized LDL cholesterol and becoming foam cells, which became the plaques in the arterial wall? The immune system can be stimulated to recognize and attack those particular germs that began the whole immune system's inflammatory response. Transfer factors that are empowered to recognize those germs can be utilized by an individual to provoke an appropriate immune response. And something called red yeast rice can also be utilized because it has been shown to dampen an inappropriate inflammatory response. So what about cholesterol? Certainly, cholesterol is implicated in atherosclerosis, and elevated cholesterol levels must be addressed. After all, if LDL cholesterol hadn't been in the arterial wall for homocysteine to oxidize, it wouldn't have been there for macrophages to ingest, and the building blocks of foam cells, and therefore of plaques, wouldn't have been available. But interestingly, 35% of people who have coronary heart disease and strokes have a total cholesterol level of less than 200 milligrams per deciliter, as you'll see here, which is considered normal. Here is a chart showing the values in a complete blood lipid or blood fat profile. The components of a lipid profile are total cholesterol, or TC, so-called good cholesterol, high-density lipoprotein, or HDL, triglycerides, and so-called bad cholesterol, or LDL. You can go to our website set up for video email subscribers to print this form out. The goal is to try to lower your total cholesterol and to lower your triglycerides and your bad LDL cholesterol while raising your good HDL cholesterol. Red yeast rice has been shown to be an effective natural supplement to achieve a more healthy lipid profile. While red yeast rice has been shown to be remarkably safe, please refer to our website for additional information prior to incorporating red yeast rice into your nutritional supplementation program. Garlic has also been shown to lower cholesterol and should be considered. Copper and magnesium can be incorporated to help normalize mildly elevated blood pressure. To help minimize the oxidative damage, that oxidized LDL cholesterol that the macrophages ingest, such antioxidants as selenium, copper, zinc, vitamin C and E, and resveratrol can be added to your supplementation. And to increase the pumping efficiency of the heart, magnesium and coenzyme Q10 have been shown to be effective. Atherosclerosis and its consequent diseases, heart disease, most strokes, and peripheral vascular disease is the #1 threat to our health. Through lifestyle changes and informed nutritional supplementation, we can lower our risk factors and enhance our probability of having a longer and more fulfilling life.